Welcome. Today, we're diving into the relationship between Spring Data JPA, and Hibernate. These technologies form the backbone of modern Java data access, but their roles and interactions can be confusing. By the end of this video, you'll have a clear understanding of how they fit together, their dependencies, and how you can use them independently or in combination. Let's start by setting the stage and introducing each layer in the stack, from the highest abstraction to the foundational database. Spring Data JPA sits at the top of the stack. It's designed to make database interactions in Java applications as simple as possible. By providing repository interfaces, it eliminates much of the repetitive code developers used to write for CRUD operations. Instead of manually handling queries and transactions, you can focus on your business logic, letting Spring Data JPA handle the rest. This abstraction is especially helpful in large projects where code maintainability and speed of development are crucial. PA, or Java Persistence API, is not a framework but a specification. It defines a standard way for Java applications to interact with relational databases using object-relational mapping, ORM. JPA outlines the interfaces and rules, but it doesn't provide the actual implementation. This means you can choose from different providers, like Hibernate, to bring JPA's capabilities to life in your application. Hibernate is the most popular implementation of the JPA specification. It's an ORM framework that handles the nitty-gritty details of mapping Java objects to database tables. Hibernate takes care of generating SQL statements, managing sessions, and ensuring data consistency. While it's often used with JPA, Hibernate can also be used directly for more control over database interactions. The foundation of this stack is the relational database itself. This is where all your data is ultimately stored and retrieved. Whether you're using Spring Data JPA, or Hibernate, the database remains the final destination for your application's persistent data. Understanding this helps clarify why each layer exists and how they interact to make data access more efficient and manageable. Let's break down the architecture. Spring Data JPA sits at the top, providing the simplest interface for developers. Beneath it, JPA defines the standard for ORM. Hibernate, as a JPA provider, implements these standards and handles the actual database operations. Finally, the database stores the data. This layered approach allows flexibility and modularity, letting you swap out implementations or use layers independently as needed. Each layer in this stack has its own dependencies. Spring Data JPA depends on JPA, but not necessarily on Hibernate. JPA can be used without Spring Data JPA or Hibernate, as long as another provider is available. Hibernate can function without Spring Data JPA, but it implements JPA. And of course, the database can be accessed directly, bypassing all these layers if needed. This flexibility is one of the strengths of the Java persistence ecosystem. You can use JPA directly in your application without Spring Data JPA. This approach gives you more control, but requires more boilerplate code. For example, you'll need to manually create an entity manager, begin and commit transactions, and handle persistence operations. While this can be powerful for complex scenarios, it's more verbose and less convenient than using higher-level abstractions. Here's a quick example of using JPA directly. You create an entity manager from the entity manager factory, begin a transaction, persist your entity, commit the transaction, and close the entity manager. This process gives you direct access to the persistence context and transaction boundaries, but as you can see, it's more involved than using Spring Data JPA. Hibernate can also be used directly, bypassing JPA's abstraction. In this case, you work with Hibernate session and transaction objects. This approach is similar to using JPA directly, but you have access to Hibernate-specific features and APIs. It's a good choice when you need advanced ORM capabilities or want to leverage Hibernate's unique features. Using Hibernate directly, you open a session from the session factory, begin a transaction, save your entity, commit the transaction, and close the session. This gives you low-level control over the persistence process and access to Hibernate's full feature set, but it also means more code to manage. With Spring Data JPA, data access becomes much simpler. You define a repository interface that extends JPA repository, and Spring generates the implementation for you. This means you can perform CRUD operations with just a few lines of code, letting you focus on your application's business logic instead of data access details. How it looks in practice: you create a user repository interface extending JPA repository. In your service class, you simply auto-wire this repository and call save, find, or delete methods. Spring Data JPA takes care of the rest, translating your method calls into the appropriate SQL statements behind the scenes. Let's take a closer look at Hibernate's internal components. The configuration object is the first thing you create, responsible for reading configuration files and building the session factory. The session factory is a thread-safe, immutable object that creates session instances and holds a second-level cache. Sessions represent units of work and provide the main interface for persisting and retrieving objects. Transactions ensure data integrity, and query and criteria APIs help you retrieve data efficiently. JPA's core components mirror those of Hibernate in many ways. The Entity Manager Factory creates Entity Manager instances, which manage entities and handle persistence operations. Entities represent tables in the database, while Entity Transaction allows you to group operations into atomic units of work. The Query interface lets you write JPQL or native SQL queries to fetch data. Spring Data JPA introduces its own set of components on top of JPA. The repository interface provides generic CRUD operations, while JPA repository adds features like pagination and sorting. Yet query annotation allows you to define custom queries, and specifications enable dynamic, programmatic query creation. Auditing features help track who created or modified entities and when. A typical application, these layers work together seamlessly. Developers interact with high-level abstractions like repository interfaces. Under the hood, these use JPA's Entity Manager to perform database operations. JPA, in turn, relies on Hibernate to generate and execute SQL. This layered approach lets you work at a high level while retaining the flexibility to drop down to lower layers for complex scenarios. Let's walk through a practical example, managing books in a library. We'll define a book entity, create a repository interface, implement a service class for business logic, and build a controller to handle HTTP requests. This example demonstrates how Spring Data JPA, JPA, and Hibernate work together in a real-world application. First, we define the book entity. This class is annotated with an entity and represents a table in the database. It includes fields for the book's ID, title, and author. Getters, setters, and constructors are included for managing the entity's state. This is the foundation for all data operations in our application. Next, we create the book repository interface, which extends JPA repository. This interface provides all the basic CRUD operations out of the box. We can also define custom query methods like find by author, and Spring Data JPA will automatically generate the implementation for us. Service layer handles business logic. Here, we create a book service class that uses the book repository to add, find, and delete books. By separating business logic from data access, we keep our code organized and maintainable. The service layer is also the perfect place to add validation or additional processing before interacting with the repository. Controller layer handles HTTP requests. In our example, the book controller class maps incoming requests to service methods. It provides endpoints for adding, finding by author, and deleting books. This structure makes it easy to expose your application's functionality as a REST-TFL API. When a request comes in to add a book, the book controller calls the add book method in the book service. The service then calls book repository save, which is handled by Spring Data JPA. Under the hood, JPA's Entity Manager and Hibernate work together to generate and execute the SQL insert statement. This flow shows how each layer plays its part in the process. For the find by author method, Spring Data JPA automatically generates the implementation based on the method name. When the controller receives a request, it calls the service, which in turn calls the repository. Hibernate translates this into a SQL select statement, fetching the relevant books from the database. Deleting a book follows a similar flow. The controller calls the service, which calls the repository's delete by id method. Spring Data JPA and Hibernate handle the translation to a SQL delete statement, ensuring the book is removed from the database. This abstraction makes data management straightforward and reliable. This layered approach allows developers to work primarily with high-level abstractions like repository interfaces and service classes. The underlying JPA and Hibernate layers handle the complexities of database interactions. This separation of concerns leads to cleaner, more maintainable code and makes it easier to adapt to changing requirements. For more complex operations, you can inject the Entity Manager directly into your service or repository. This gives you full control over the persistence context and allows you to write custom JPQL or native SQL queries. It's a powerful option when you need to go beyond what repository interfaces provide. In our example, we create a custom book repository class that uses the Entity Manager to find expensive books by a specific author. By writing a custom JPQL query, we can retrieve exactly the data we need. This approach is ideal for advanced scenarios where standard repository methods aren't enough. Summarize: Spring Data JPA, JPA, and Hibernate each play distinct roles. Spring Data JPA provides the highest level abstraction, focusing on developer productivity. JPA defines the standard for ORM, while Hibernate implements that standard and handles the details of database interaction. Understanding these differences helps you choose the right approach for your project. Deciding which layer to use, consider your project's needs. If you want rapid development and minimal boilerplate, Spring Data JPA is ideal. If you need more control or want to use features not supported by Spring Data JPA, working directly with JPA or Hibernate might be better. The flexibility of this stack means you can mix and match as needed. Spring Data JPA is best when you want to focus on business logic and let the framework handle data access. It's perfect for standard CRUD operations, rapid prototyping, and projects where maintainability is a priority. The automatic implementation of repository interfaces saves time and reduces errors. Using JPA directly is a good choice when you need fine-grained control over transactions and persistence. It's also useful when you want to avoid framework-specific features and stick to the standard API, making your code more portable across different JPA providers. Direct use of Hibernate is recommended when you need access to advanced ORM features or want to leverage Hibernate-specific optimizations. This approach is more complex, but gives you the most control over how your application interacts with the database. One of the strengths of this stack is the ability to mix layers. You can use Spring Data JPA for most operations, but drop down to JPA or Hibernate for complex queries or performance optimizations. This flexibility lets you tailor your data access strategy to your application's unique needs. Performance is always a concern in data-driven applications. Spring Data JPA and Hibernate both offer caching, batching, and other optimizations. Understanding how each layer handles queries and transactions can help you fine-tune your application for maximum efficiency. Using abstractions like Spring Data JPA makes testing and maintaining your code easier. Repository interfaces can be mocked or stubbed in tests, and the separation of concerns means you can update one layer without affecting others. This leads to more robust and adaptable applications. Despite their power, these technologies can introduce pitfalls if not used carefully. Common issues include lazy loading exceptions, transaction mismanagement, and performance bottlenecks from inefficient queries. Understanding each layer's responsibilities helps you avoid these problems. Get the most out of Spring Data JPA, JPA, and Hibernate. Follow best practices. Use repository interfaces for standard operations, leverage custom queries for complex needs, and monitor performance regularly. Keep your entities simple and avoid mixing business logic with data access code. Both Spring Data JPA and Hibernate offer advanced features like auditing, dynamic queries, and caching. These can help you build more powerful and efficient applications. Explore these features as your project grows and your requirements become more complex. Spring Data JPA, JPA, and Hibernate all have strong communities and extensive documentation. If you run into issues or want to learn more, there are plenty of resources available, from official docs to community forums and tutorials. Don't hesitate to leverage these when building your applications. Let's recap what we've learned. Spring Data JPA provides the highest level abstraction, making data access easy and efficient. JPA defines the standard, and Hibernate implements it, handling the details of ORM. Each layer can be used independently or together, giving you flexibility and control over your data access strategy. In real-world projects, you'll often use a combination of these technologies. Start with Spring Data JPA for rapid development, then drop down to JPA or Hibernate for advanced needs. This approach lets you build scalable, maintainable, and high-performance applications that can adapt as your requirements evolve. Experts recommend starting simple and only introducing complexity when necessary. Use Spring Data JPA for most cases, but don't hesitate to use JPA or Hibernate directly when you need more control. Always keep performance and maintainability in mind as your application grows. Java persistence ecosystem continues to evolve. New features and improvements are regularly added to Spring Data JPA, JPA, and Hibernate. Staying up to date with these changes ensures your applications remain modern, efficient, and competitive in the ever-changing tech landscape. Thanks for joining us on this deep dive into Spring Data JPA, JPA, and Hibernate. Understanding how these layers interact and when to use each one is key to building robust Java applications. Whether you're a beginner or an experienced developer, mastering these technologies will help you create efficient, maintainable, and scalable solutions for any project.